Hi guys, graphing sine and cosine is what we're going to do today. So there's a few things we need to know about those two graphs. The first thing is that both of those functions are what we call periodic functions, which means they have their graphs repeat in intervals. So there's sections of their graphs that are just going to constantly repeat the whole graph. That piece that repeats is what we call a cycle. So it's going to be the shortest piece of our graph that is repeated. And then we have what we call the period, and the period is the length of that cycle, so the length of the repeating section. So we're going to look at graphing sine. In order to graph sine, we're going to look at our unit circle. So when we go to graph, our xy point on our graph, on our coordinate plane, will come from the radian value, comma, the y value. So our x value will be the radian value, y value will be the actual y value on our unit circle. So let's take a look. Here is our sine function. So we're just going to go from 0 to 2 pi because that's once around the unit circle. So we start at 0, 0. That would be 0 radians. The y value of that point on your unit circle is 0. When we go up to pi halves on our unit circle has a y value of 1. So that's where this point comes from. We go back to pi. Pi is our radian value. Our y value is 0 on our unit circle. If we go to 3 pi halves, our y value is -1. So that's where this point comes from. And then we're back up to 2 pi. Our radian value would be 2 pi. The y value on our unit circle is 0. So this creates our first cycle of the sine function. So this cycle would just be slid over and repeated, slid over and repeated, and it can go to the negative values as well. So what we're looking at is one cycle. The period means the length of that cycle, and it took us from 0 to 2 pi to get that period. So our period of the sine function is always 2 pi. If we look at our cosine function, so we're still going to use a unit circle. This time our xy coordinate point on our graph comes from our radian value and then our x value, because if you remember, cosine correlates to x on our unit circle. So we're going to graph this. When we start on our unit circle at 0 radians, the x value is 1. So that's where this point comes from, 0, 1. At pi halves, or 90 degrees, our radian would be pi halves. Our x value is 0. That's why it's on the x-axis. At pi, our radian value is -1. Or our y value, or excuse me, our x value is -1. When we go down to 3 pi halves, or 270 degrees, our x value is 0. And then when we get all the way back around to 2 pi, our x value of 2 pi is 0 as well. So radian, comma, x value, radian, comma, x value, all of these points come from your unit circle. The radian value and then the x value is what gives you the coordinate points to graph here. This is now one cycle of our cosine function. So again, you could take this cycle and slide it each way and just keep repeating. That's how you build your cosine function. One cycle is still 2 pi length. So our period is still 2 pi for cosine. We're going to talk about something called the amplitude. The amplitude kind of talks about the height of our graph. So we have a max and a minimum on our graph, and we're going to take half that distance to get our amplitude. Since we're talking about distance, it will always be positive. So here we have a graph. We're graphing y equals 3 sine of 4x. So I went through and marked some key pieces of information. So all of these dashed lines, you can maybe kind of see that it changes colors. I trace those dashed lines to show a period. So this one's pink, there's one period, then we go to blue, there's another period, this one's yellow, really hard to see, there's a third period, and a fourth period. But first of all, I want to talk about the amplitude. Remember, the amplitude is half the distance between our max and our min. So we go from +3 down to -3, so that's a total distance of 6 divided by 2 is 3. Another little hint, find the center of your graph. Ours happens to lie on the x-axis, and then find the height from your center of your graph to the maximum, which is 3. So our amplitude for this graph is 3. Now we just talked about how there were 4 cycles from 0 to 2 pi, 4 repeating sections. That means that our period of 1 cycle is 2 pi divided by those 4 cycles, meaning we have a period of pi halves for this function. Okay, if you look here at our formula, amplitude corresponds to that number. There were this many cycles in our graph. So let's look at another one to see if the same thing applies. So we have y equals -2 sine of 3x. This negative means we reflect it over the x-axis. But we're going to find our amplitude. So again, half the distance from our max to our min. So our max to our min goes from 2 to -2. So a distance of 4 divided by 2, your amplitude would be 2. If you find the distance from the center of your graph to your max, that's also 2. So amplitude is 2. There are 3 different cycles. I again dashed the different cycles. So there are 3 cycles, which corresponds to that number, meaning that your period takes this 0 to 2 pi and divides by how many cycles? So 2 pi thirds. Couple hints, properties of sine and cosine, just kind of to get into writing what I just said. If you're given your function, a sine of bx or a cosine of bx, your amplitude will always be the absolute value of that first number, so that a value. B tells you how many cycles there are from 0 to 2 pi, which we just looked at with those graphs. And then our period can be found by taking 2 pi divided by that b value. Okay, I want to actually graph a couple. So y equals 4 cosine of 2x. The first thing we want to talk about is what is my amplitude? It comes from that number. So our amplitude is 4. And then our period is 2 pi over that b value. So 2 pi over 2 gives us a period of pi. So I'm going to graph. I make my graph go from 0 to 2 pi. That's pretty standard. But I know that my period, or the length of one of my cycles, is from 0 to 2 pi, or excuse me, 0 to pi. Okay, so I know if I start here, I need to end there at pi. So when I go to graph this, I'm just going to look at this part for right now. Cosine always, if you go back to the beginning of the video, cosine always starts on your y-axis. Well, our amplitude was 4, so it has to start at 4 on the y-axis, so 0, 4. I know my ending value has to be at 4 as well, with a period of pi. So I go over to pi and then up 4 to get my ending point. Okay, well, I know halfway between those at pi halves, I better be down at -4 because my distance from the x-axis to my minimum has to be 4 as well. And then I just connect the dots. And I know between 0 and pi halves, halfway between that, I should cross the x-axis. So I went from 4, hit the y-axis at pi force, go down to -4 on my y-axis, back through the x-axis and up to my ending point. There is one cycle. We got our cycle done in a length of pi units. And then I just repeat. Same idea. I'm starting now at pi, 4, ending at 2 pi, 4. I know partway through the middle, or halfway through pi and 2 pi, I should be down at -4, and I can connect the dots. We're going to look at one more graph. So we're going to graph 3 sine of 1/2 x. First thing is always to find our amplitude. Our amplitude is 3 based off that a value. Our period is 2 pi divided by our b value. We don't divide fractions, we multiply by the reciprocal. So our period is 4 pi, meaning in order to get one cycle done, I have to go all the way out to 4 pi. So sine starts at our origin and goes up. Okay, I know I'm going to start at my origin, and I better end at my origin, clear out here at 4 pi. Halfway between, I need to be at my origin as well, because I have to go up and down. So halfway between my max and my min, I should be at the origin. So half between 0 and 4 pi is where we get that 2 pi. And then if we look from our origin back to our x-axis, we know we have a maximum. So halfway between 0 and 2 pi, we have to get to our amplitude of 3. So we go 0, 0 up to pi, 3, and then back down to our x-axis. Halfway between 2 pi and 4 pi, we need to be down at our minimum, which is -3, and then back up. So one cycle took us a period or a length of 4 pi.